Okay guys, so welcome ulit sa ating YouTube channel. Ito na lesson 22 sa ating advanced calculus. So ito ay continuation lang ng ating function. So more properties pa about function. So let's have theorem number 7. So theorem number 7, so let f be a function mapping from a domain going to real number and g a function going to from e going to real number, and suppose that f of d is a subset of e. If f is continuous at c element of d, and g is continuous at f of c element of p, then g compose f is continuous at c. So ito na yung composition of function. So kailan ba natin masabing continuous yung composition ng dalawang function? So before that, drawing muna natin or illustrate muna natin ano ba itsura niyan. So suppose ito yung domain D. So let's say ito yung domain D. Okay, so let's say ito yung point C. So this is E. Okay, so suppose this is E. Okay, then nagmap siya papunta doon. Ito yung f of C. So ito yung f of x na function natin. Okay, then ang mangyayari, ito yung function g. So ito yung function g, magmamapping somewhere dito sa point na to, in which siya si g of f of c. Okay, so ayusin ko lang konti. Siya si g of f of c. Okay, so ibig sabihin yung domain niya is somewhere dito galing kay C punta doon. So ito yung sinasabi niya na siya ay continuous at C. Yung G circle F is continuous at C. So again, ito yung G of X, kasi ito yung kanyang composition. So ayun yung kanyang illustration pag sa ating composition. So ngayon, paano natin ipoprove na siya ay continuous? So paano natin ipoprove na yung G circle F is continuous at C? So check natin. Meron tayong dito, no? Suppose f of d is a subset of d. So kung naaalala nyo, meron tayong definition. Ito yung proof. So ganito ko siyang way gagawin. Okay, so let tayo. So let x sub n b subset or b element, or tama, b subset ng d with x sub n tends to C. So meaning, since yan yung ginawa ko ulit, gumawa ko ng sequence dun sa domain ng f, okay, na kung saan yung kanyang limit is yung C, kasi nga yung f is continuous at C. So since f is continuous at C, then yung by definition natin, f of x sub n approaches f of C. Okay, then since G is continuous at f of C, so pwede natin gawin yan. So pwede natin gawin to, yung G of f of x sub n. So kunin natin x sub n. This implies that G of f of C, which means, ano ba ibig sabihin nito? Ibig sabihin nito, ito ay G circle f of x sub n approaches G circle f of C. Okay, so therefore G circle f is continuous at C, kasi nakikita ko na doon. So again, ito ay equal din doon. Okay, so ganun lang siya kasimple. So again, para pag nag-prove ka na function, mag-let ka lang ng sequence na element ng domain, tapos with sequence na nagko-converge dun sa C, kung saan man gusto natin, kung saan siya continuous, then by definition, yung f, since f is continuous at C, then f of x sub n is approaches to f of C. Then gamitin na natin yung mga natutunan natin from algebra or from previous theorem. Okay, so ganyan yung gagawin nyo pag mga proving na ganyan. So kung napansin nyo, ginawa ko na yan last time. Okay, next is let's have proposition number 1. So proposition 1, let D subset of real number and C element of D. So imagine mo so may domain tayo na real number, element ng subset ng real number, and C element of D. So set D1 to be X element of D such that X is less than or equal to D. Okay, so ito yung domain. Set D2 is equal to X element of D such that X is greater than or equal to C. Sorry, pakibago to. Okay, again, given two function, f sub 1 mapping from D1 to real number and f sub 2 mapping from D2 to real number, then and f sub 1 and f sub 2 are continuous in their domain, and we define f of x is equal to f of x sub 1 f sub 2 f of x sub 2 for x element of D1, x element of D2, then f is continuous of D2. So ito yung tinatawag na piecewise function. So ito yung parang mathematical definition ng piecewise, so piecewise function. Okay, so tama naman ako napapansin nyo. So hindi lang lagi so kumbaga may corollary pa tong proposition na to, or kumbaga may theorem pa to na kung saan marami yung f. So f hanggang f sub n. Pero ito nga, ano ba ibig sabihin sa drawing? Kunyari pag dinrawing lang natin siya. So pag nagdrawing tayo ng piecewise function, hindi lagi ganito itsura. Depende kasi sa domain. So assuming yan yung f and d. So assuming ito yung d1. So assuming ito yung point C. Okay, so assuming andito yung d1. Assuming andito yung D2. Okay, so at some point, function dyan, mag-map dyan. Okay, then, at some point sa kabila, function dyan sa kabila. So, ito yung f sub 2. Then, ito yung f sub 1. Okay, so let's say yun yung point. Okay, ganyan usually itsura yan. So, pag continue sila. So, pag continue, so mismong buong function ko dun sa C. Ibig sabihin, parang nag-intersect yung dalawang function natin o yung piecewise function natin dun. Okay, pero ngayon, usually, ang mga piecewise function, may mga piecewise function na hindi continuous eh. So, yung mga example is yung putol-putol. Kung baka putol dito, sunod na graph dun sa ganun. Okay, may mga ganung klase kasi na piecewise function. So, pakibantayan din. Okay, so nakapagbigay naman ako ng example ng piecewise function. Dati pa naman, hindi ko na kailangan pabigyan ng example ng piecewise function. So, aware ka na dyan kung ano yung piecewise function na yan. Okay? So, kung paano mo i-treat si function dati, kunin yung 1-to-1, kunin mo yung pagiging surjective, kunin mo yung inverse, same lang din dito. Pinagkaiba nga lang, nakadepende ka sa domain. So, tandaan mo yun ha. Nakadepende ka sa domain nung function o nung part ng function, nung part ng piecewise function natin. Okay? Then, let's have another definition. So, let D subset ng real number, then we say that D is closed if for every sequence x sub n subset of D which converges, then its limit is in D. Okay, so ano ba yung mga possible example nito? So, ano lang, parang inaano lang nito. Kunyari, meron akong D. So, masabi kong close si D. So, ano ba yung tsura ng close? Kung naalala nyo, ang pagiging close, somewhat. So, para maging close ako, D is close if yung form is ganito, A comma B for A less than or equal to for A less than B. Okay, so close siya pag ganyan yung itsura. So aware naman kayo sa may close interval. Okay, so sabi nga niya, ito yung definition na to, magiging close ako or ganyan yung form ko if for every sequence, so sa lahat ng sequence sa loob ng D, so sa loob nito which converges, then its limit is on D. So meaning kung merong x sub n dito, so kung meron daw x sub n, okay, na subset nito, okay, then yung limit ng x sub n natin approaches to some, say, alpha element din nung A comma B natin. Yun yung ibig sabihin netong definition nito. Okay, so example, para masabi natin close or what, sample na lang tayo. So example, so for number 1, so for example, we have negative 2 comma 5 close. Okay, so obviously hindi siya close kasi open sa negative 2, close sa 5. So it is not close or is not close. Okay, so by structure alam mo na hindi siya close, pero yan, gawa ka ng sequence. So it is not close. It is not close because gawa tayo ng reason. Because for example, meron akong sequence na negative 2 plus 1 over n. Okay, negative 2 1 over n. Ito ay element nung negative 2, 5 na yan. Pero yung kanyang but, yung limit ng negative 2, yung limit ng negative 2 plus 1 over n approaches to negative 2. Pero yung negative 2 is not an element ng negative 2, 5 natin. Kasi walang negative 2 dyan. Okay, so ayun yung ibig sabihin ng definition. Ayan. So another example, so what if close naman po? So for example 2, so ano AB, so ito nga example ko kanina, AB is close. Okay, so kuha tayo ng sequence, kunwari if x sub n converges dito, so if x sub n is any sequence, so kuha ko ng sequence, any sequence in AB, then yung a sub n o yung a, then yung a is less than or equal sa x sub n, less than or equal sa b. Okay, if it converges to some c, okay, then lagay tayo, then yung a less than or equal to c, less than or equal to b. So ibig sabihin nasa loob yung c. Okay, so again, nasa loob yung x sub n, ibig sabihin nito, tas nasa loob yung c. Okay, so which implies, so this implies lang na si c element ng domain na AB o ng closed interval AB. Therefore, a comma b is closed. So by structure pa lang naman, aware ka na close. So ito yung I think mathematical definition para mas maintindihan mo. Bakit nga ba close? Bakit nga ba hindi? Bakit nga ba not close? Yung isang interval. So ito yung isang definition na kung saan very useful. So medyo intuitive kasi medyo malalim siya. Okay. So kasi kung nasa engineering mathematics ka lang, so by structure titignan mo lang, hindi yan close, hindi yan open, or open yan, hindi yan close, half open yan, half close yan. Okay, so ganun lang. Pero dito nga, since analysis tayo, pag-aaral natin talaga literal yan. So by term, in a sense of sequence, ganun yung mga gagawin natin dito. Okay, so let's have proposition number 2. Let D be a subset of real number, be closed and bounded, and let F be a function mapping from D to real number, be continuous. Then for I, F is bounded on D, that is F of D is a bounded set. Number 2, F attains its bound on D. So ipoprove ko yung dalawa na yan. I think pwede naman, kaya naman. So by the use of Weierstrass, by the use of Bolzano-Weierstrass. So, ipoprove ko to una. So, yung I. So, ito yung proof of I. Lagay ko lang dito, proof of I. Proof of I. Okay, so by contradiction. So, takihin natin siya by contradiction. So, di ba sabi ko nga sa inyo, mas madali mag-prove sa advanced calculus or sa analysis by contradiction. Kasi kung lalo pag mas marami ka ng alam na definition sa property. So, kunyari, contradict mo lang yung fact na binigay. So, sabi nga niya, let D be a subset of real number, thus be closed and bounded. So, since closed and bounded siya, what if naman hindi siya bounded? So, yung atake ko, so what if naman hindi siya bounded? Okay, so check natin. Suppose F. So, suppose F is not bounded. Is not bounded on D, on sa domain niya. Okay? So, kung ganun nangyari, ano ba ibig sabihin? Marami possible na mangyari. May mag-exist na x sub 1. So, ito yung mga mangyayari. So, this implies there exists x sub 1 element ng domain such that yung absolute value nung f of x sub 1 is greater than 1. So, assuming lang may isang ganon. Okay, so may x sub 1 daw na kung saan unbounded siya. Okay, greater than 1 siya. Ngayon, another thing, meron ulit. So, there exists x sub 2. So, sabi, bounded lang daw siya sa 1 o mas mataas sa 1. Ngayon, meron pa yan. Since meron ganyan, since mas mataas siya sa 1, ibig sabihin meron pang x sub 2. So, meron daw x sub 2 na kung saan yung absolute value ng f of x sub 2 is greater than 2. Okay, and so forth. So, tuloy-tuloy mangyayari yan kung mapapansin nyo. There exists x sub n element of D such that yung absolute value ng f of x sub n, okay, is greater than n. Okay, so kung napansin nyo, ano nangyari? Nagkaroon tayo ng sequence. Okay, so nasan din nyo x sub 1 unbounded siya. So unbounded siya kasi greater than 1 pa. X sub 2 unbounded siya kasi greater than 2 pa. X sub n bounded siya kasi x sub n pa. Pero anong nangyari? Nakaka-form ako ng sequence na x sub 1 up to x sub n. So I think we attain a bounded sequence. Sir, bakit bounded? Bounded siya kasi may some number na nagbabound sa kanya. X sub 1, x sub 2, x sub 3, x sub 4, up to n. So meaning, hanggang n lang yung kanya maximum. Although gagalaw pa. Pero at least, napapansin natin, okay, bounded siya. So we attain a bounded sequence. So lagyan natin a bounded sequence x sub n subset of D. So sabi ko nga, naalala nyo, sa Bolzano-Weierstrass theorem, so kung meron kang bounded sequence by Bolzano-Weierstrass theorem, so by BWT, so by Bolzano-Weierstrass theorem, okay, this sequence, so the sequence x sub n has a convergent subsequence. Okay, so let's say subsequence x sub n sub k. Okay, so ngayon, since convergent yung subsequence, so sabi nga no, kung bounded yung sequence natin, automatic may subsequence siya na convergent. Okay, so yun yung sabi ni Bolzano. So kung ganun yung nangyari, ngayon if yung x sub n sub k approaches to x, then alam natin, then x is an element of D. Okay, so ano ibig sabihin? If x sub n approaches to x, so by definition na isa kanina, if x sub n, okay, so si x sub n sub k approaches to x, tapos x element of D. So ito yung sabi nun, where the limit is element of D. Therefore, ano masabi mo? Therefore, D is close. So therefore, D is close. Okay, since D is close, ano masabi nyo? Since D is close, then ano ba masabi? Kung close siya, therefore continuous siya kasi nabanggit din dito eh. Since f is continuous, so since f is bounded tapos siya ay continuous, so since f is continuous on D, another thing, since f is continuous on D, okay, then f is continuous at x. Okay, and so f of x sub n sub k implies f of x, which is a contradiction. So ano ibig sabihin? Ang ginawa natin kanina, ang assumption natin, yung sequence ng f of x sub n natin is unbounded. Pero nagkaroon tayo ng subsequence na subsequence ng x sub n natin in which nag-approach siya f of x. Okay, so meaning may limit siya sa taas. Okay, so ano ibig sabihin nito? So ibig sabihin lang f is bounded. So therefore, lagay ko na lang, therefore f is bounded kasi nakahanap na tayo ng contradiction. Okay, so ganun siya ipoprove using si Bolzano-Weierstrass theorem. So number 2, f attains its bound on D. So that is, ano ba ibig sabihin nun? So lagay ko lang dito, nakalimutan ko ilagay. That is, there exists R and S element of D such that dalawang mangyari dito. Una, f of R is equal to infimum of f of x, okay, then x element of D, and f of s natin is equal to the supremum of f of x for x element of D. Okay, so ano naman ibig sabihin? F attains its bound. So meaning, nakukuha ko yung aking boundary dun sa may supremum ako dun sa aking boundary. Okay, so paano naman ipoprove to? Sinabi na dito, no? Yung proof lang ng 2, napakabilis lang. So kailangan na mangyari yan. So proof of 2. Okay, so unahin ko na lang. Since okay na tayo sa 1, since f is bounded on D, then f of D is bounded set. Ibig sabihin nito. Okay, then f is bounded set. So ibig sabihin, since f is bounded, then f of D is a bounded set. So since f of D is bounded, sorry. Okay, then we define M to be the supremum of f of D. Yan yung isa. And we define M, na small m, to be the infimum of f of D. They are both exist. Okay, so that is done. So ano ba lang ibig sabihin? Since bounded na ako, automatic, meron na akong supremum sa infimum. Ganun lang kasimple yun. Bakit, sir? So, aware kayo nun, no? Makita mo nga lang yung number sa interval. Alam mo nang meron siyang supremum sa infimum eh. Okay, nawawalan lang siya ng supremum sa infimum pag may infinite saka may negative infinite saka positive infinity ka nakikita. Pero since f of D is bounded set, so ibig sabihin yan, siya ay closed interval or something. Therefore, meron siyang supremum sa infimum, which is dinefine ko lang. Okay, so ganun lang yung ibig sabihin. Yan. Okay, so let's have example para maintindihan nyo rin yung ako dyan. So, hindi masyadong titibig example ko, pero ginrap ko na rin siya using GeoGebra. Hindi ko na masyadong hirapan sarili ko kasi gagrap pa natin, tatagal pa yung video. Okay, so number 1, f of x equal to 1 over x minus 1 on 1, 5. So obviously this is not closed but bounded. Okay, so this is not closed but bounded. Bakit siya hindi closed? Kasi may open interval sa 1. So lagay ko lang, this is not closed. This is not closed but bounded. Okay, kasi nga hindi siya close dahil dun sa 1. Okay, so pag dinrap, ano pa yung tsura na ito sa graph? So kung napansin mo sa domain niya, sa 1 lang saka sa 5, no? So kung ito yung 1, ito yung 1, ito somewhere yung 5. Okay, so somewhere nandito yung 5. Somewhere na reach niya. So kung dito yung 1, anong nangyari? Asymptotic siya dito. Okay, so kung i-graph mo yan, asymptotic siya sa line na yan, kasi ganito magiging itsura ng function. Okay, so kumuha ka ng 1.0001, so as 1.999 something, nandiyan lang yung somewhere. Okay, ganyan lang yan. Yan yung ibig sabihin ng function na yan. So again, that is not closed but bounded siya. So next example, f of x is f of x equal to x minus 1 over x per x element ng 1, positive infinity. So kung napansin mo, ano ba ibig sabihin nito? Siya ay close pero unbounded. Ano ibig sabihin? Close sa umpisa pero unbounded. So dito naman, not close siya sa umpisa kasi pero bounded, kumbaga tumigil. Okay, dito naman siya ay not close pero unbounded. Okay, so lagi ka lang close. This is close dahil kay 1, dahil dito, but unbounded dahil kay positive infinity. So disregard mo muna yung interval na dasa dapat close eh. Hindi ganoon. Dito lang kasi ibig sabihin na sa graph niyan, pinalagyan graph natin. So let's say ito yung graph. So let's say ito yung 1. So andyan yung maximum value niya. Somewhere nagre-reach dyan yung maximum value niya. Okay, so okay, ito yung 1 natin again. So yung function natin na yan is somewhere na ganito itsura. Okay, bounded siya kasi hanggang 1 lang. Okay, so close siya dyan. Kumbaga, abot ako hanggang 1 pero unbounded ako pagdating dito sa taas. Tapos, ay nga, unbounded nga lang kasi dire-diretso lang yung angat. Ganun. Okay, although asymptotic yan, pero tuloy-tuloy yan, unbounded yan. Hindi natin alam saan matitigil. Okay, unbounded yung mismong, yung ating term na to. Okay, o yung ating mga sequence dito. O form. Okay, so ayun yung example nito. So, ito yung mga more properties dito. So, in next video, sana panoorin nyo rin. Next video is all about inverse naman. Tapos yung uniformly convergent. So, related pa rin to dito. So, ginagawan ko lang ng way, property na nilalagyan ko ng mga sequence kasi kailangan ko talagang i-relate yung function sa sequence kasi doon naman talaga nag-umpisa lahat sa sequence. So, again, thank you for watching. Hoping na panoorin mo yung next video natin.